In September 1977, humanity launched a spacecraft that would eventually travel farther from Earth than any machine had ever gone before. Voyager 1 was designed for a remarkable planetary mission, but its journey would ultimately become something far greater. After visiting Jupiter and Saturn and returning extraordinary observations of these distant worlds, Voyager 1 continued outward. Instead of stopping after completing its original objectives, the spacecraft became humanity's long-distance messenger, heading toward a region where the influence of our Sun gradually gives way to the environment between the stars. For decades, Voyager 1 continued moving through the outer solar system. Its destination was the heliopause, an enormous boundary created by the interaction between the solar wind and the surrounding interstellar medium. The solar wind continuously streams outward from the Sun, creating a vast protective region called the heliosphere. But that protective bubble does not extend forever. Eventually, the solar wind weakens enough for interstellar space to become dominant. In 2012, Voyager 1 crossed this boundary, becoming the first human-made spacecraft to enter interstellar space. The achievement was historic because Voyager was no longer simply exploring another planet or moon. It was now measuring the environment beyond the Sun's direct influence. And what it encountered was not the empty darkness scientists might casually imagine when thinking about interstellar space. Voyager detected changes in plasma conditions, energetic particles, and magnetic fields that revealed a surprisingly complicated environment. The region beyond the heliopause is not completely empty. It contains extremely thin plasma, magnetic fields, cosmic rays, and disturbances that can travel through the interstellar medium. Voyager's instruments allowed scientists to study these phenomena directly. Some observations challenged earlier expectations about how smoothly the transition between the heliosphere and interstellar space should occur. Instead of behaving like a simple wall, the boundary appeared to be a complicated region where solar and galactic influences interact. This discovery changed the way scientists think about the edge of our planetary neighborhood. The heliosphere is not a rigid shell surrounding the solar system. Its size and shape can change depending on the pressure of the solar wind and the surrounding interstellar environment. That means our solar system is constantly moving through a much larger cosmic environment. As the Sun travels through the Milky Way, it encounters different densities of gas, magnetic fields, and energetic particles. These external conditions can influence the shape of the heliosphere and determine how effectively it protects the planets from some high-energy particles originating beyond the solar system. Voyager 1 is therefore doing something extraordinary. It is giving scientists a direct opportunity to study the environment outside our solar bubble. Every measurement helps researchers understand what lies beyond the region dominated by the Sun and how our planetary system interacts with the wider galaxy. And the spacecraft itself is almost as fascinating as the discoveries it has made. Voyager 1 was built during the 1970s. Its technology is primitive compared with modern spacecraft. Its computers have extraordinarily limited memory by today's standards, yet the probe has survived for nearly half a century. It has endured extreme cold, radiation, enormous distances, and the gradual deterioration of its power system. Its electricity comes from radioisotope thermoelectric generators, whose available power slowly declines with time. Engineers therefore have had to make difficult decisions. Systems are switched off. Heaters are carefully managed. Software commands are transmitted across billions of kilometers. Every remaining watt of power matters. Yet Voyager continues. Its survival is one of the greatest demonstrations of long-term engineering reliability in human history. But its journey is not finished. Even as its instruments gradually lose power, Voyager 1 continues moving away from the Sun. And somewhere beyond the edge of the heliosphere, an aging spacecraft is still carrying humanity's questions into the darkness. The deeper it travels, the more clearly we see that the boundary of our solar system is not an ending. It is a doorway. Voyager 1 is now traveling through an environment no human being has ever physically visited. Far beyond the planets, beyond the familiar domain of the outer solar system, the spacecraft continues its silent journey through interstellar space. Its scientific mission has become a remarkable experiment in understanding the space between stars. Voyager's measurements have revealed that interstellar space is not simply a completely empty void. It contains particles, magnetic fields, plasma waves, and energetic radiation. These invisible features create a constantly changing environment that scientists are only beginning to understand in detail. One of the most important lessons from Voyager is that the boundary surrounding our solar system is far more complicated than a simple dividing line. The heliosphere interacts continuously with the interstellar medium. Solar activity can send disturbances outward, while conditions beyond the heliosphere can influence how that protective bubble behaves. This interaction matters far beyond Voyager itself. Other stars throughout the galaxy possess their own planetary systems, and many of those systems exist inside similarly complex environments. Understanding our own heliosphere provides scientists with an important reference point for thinking about how other planetary systems may be exposed to their galactic surroundings. In that sense, Voyager is not merely exploring where we are. It is helping us understand what other worlds might experience. But perhaps the most extraordinary aspect of the mission is its age. When Voyager 1 launched, personal computers were still primitive. The spacecraft was designed using technology from an era that seems almost ancient compared with today's digital world. Yet the probe has continued operating across an unimaginable distance. Its power source weakens every year. Its instruments cannot operate forever. Eventually, the spacecraft will reach a point where there is simply not enough electrical power to continue communicating with Earth. Mission engineers have already demonstrated remarkable skill in extending its lifetime. They have carefully managed its remaining energy, adjusted spacecraft systems, and developed solutions for problems that could never have been anticipated when Voyager was launched. But eventually, even the best engineering cannot defeat time. One day, Voyager 1 will transmit its final scientific measurement. Then its final radio signal will arrive. And silence will follow. But the spacecraft itself will not stop. Voyager 1 will continue moving through the Milky Way, carrying a unique artifact from Earth into the distant future. Attached to the spacecraft is the Golden Record, created as a symbolic message from humanity. It contains sounds, images, music, and greetings intended to communicate something about our civilization to any distant intelligence that might someday encounter it. The chances of such an encounter are impossible to predict. The galaxy is enormous. The distances between stars are almost beyond human comprehension. Yet the record represents something more important than the probability of discovery. It represents intention. Human beings looked at the night sky and decided to send a piece of their world into it. Voyager carries evidence of our curiosity beyond the boundary of the solar system. It carries a message that says we were here. And even after its instruments stop functioning, the spacecraft will continue its journey. The planets will change. Continents will move. Civilizations may rise and disappear. The Earth itself will eventually become something very different from the world we know today. But Voyager 1 will continue drifting among the stars. Its mission therefore has two endings. One is scientific. The moment its remaining power can no longer support communication. The other is almost timeless. The spacecraft continuing through interstellar space long after its creators are gone. That is what makes Voyager 1 so extraordinary. It began as a scientific mission to explore the outer planets. It became humanity's first true expedition into interstellar space. And now it stands as a reminder that exploration does not always require knowing what waits ahead. Sometimes, it begins simply with the courage to send something beyond the horizon. Voyager 1 crossed that horizon decades ago. And it is still going.